Afternoon, everybody. We're just waiting for a few more people who may be running a little bit late, so we'll commence in a couple of moments. Well, good afternoon, everyone. I'm Andrew Percival, the Head of Sales for Trina, Australia and New Zealand, and I look after the utility solutions, which includes modules, tracker and BESS. It's my absolute pleasure to welcome you to today's webinar, Building Resilience, Tackling Extreme Climate Challenges with Trina Solutions, organised, of course, by Trinasolar. Australia has experienced numerous extreme weather events recently. In fact, just on the weekend, Sydney faced sweltering temperatures up to 39.3 degrees, with Observatory Hill recording 37.1 degrees, in fact. Earlier this month, ex-tropical cyclone Alfred caused significant disruptions and power outages. Although traditional PV solutions have reliably served our industry under normal conditions, these extreme events really do demonstrate that there is an increased urgency to ensure high reliability of PV products in extreme climate conditions. So today we're very proud to launch our new Shield Extreme Climate Solution. Our esteemed panel of experts will be sharing on our global standards, innovative methods and performance of our new Shield Extreme Climate Solution module and how it tackles climate challenges. Today, we'll have Eason Qian, who is a technical expert for solar and commercial products in Greater China at the TUV Rheinland Group, who will discuss hail testing, standards, methods, and performance of Trinasolar's NED 19RC.20. We'll also have Charlie Chai, who is our Reliability R&D Manager at CGC. Charlie will present on the reliability of PV products under extreme climate conditions, including challenges and solutions. And of course, last but not least, we'll have Boon, who is the Head of Modules for Asia Pacific at Trinasolar, and he will be exploring building resilience, tackling extreme climate challenges with Trina Solutions. So ladies and gentlemen, now let's begin with our very first speaker. Please give a warm welcome to Eason Qian. Thank you, Eason.
Thank you, Andrew. Okay, I will share my screen. Okay. Well, good afternoon, ladies and gentlemen. Welcome to today's webinar. My name is Eason Chen and from TUV Rheinland, Shanghai. Today, I would like to share the topic of the performance of Trinasolar's NED 19RC.20, the new product for its performance in hail tests and for the static mechanical load test, which were tested in our lab in China. Okay. Today, I would like to introduce into 4 parts. Firstly, I would introduce the background of the hail test and for the static mechanical test and for the detailed test method, for the source and for some details for both tests. And last but not least, I would like to introduce the performance of the Trina new products. Okay. So let's start from the first part. Okay. From the when we're talking about the hail, we know hail is a form of precipitation that consists of frozen ice. It falls from the sky like rain and snow, and the formation of the hailstones occurs when moisture is rapidly forced upwards in the cross during an draft. The extreme temperature that in the crust would cause water droplets to freeze, forming solid, uh, round, and hailstones. When survived a thunderstorm occur, they can generate large hailstones due to the intense weather conditions. However, the size and the weights of the hailstones may not be worrisome as the speed at which they travel. Hailstones can travel between the speeds of the 10 mph and up to 75 mph. And this is the reason why they can cause significant damages to our, for example, we can see from the picture for our vehicles, yes, from the smaller hail or even the larger hail. And not only to the cars, but also to our when we care about the solar panels, yes, they can have the cause the significant damage to the solar panels. Not only we can see to the front glass or to the cause the macro cracks for the solar cells and thus reduce the power output. And even the worst case, you can see from the power stations that the modules are almost totally damaged due to the very significant high impact. Yeah. So the next part I would like to talking about the standard. Yes, we will refer to the IEC 61215, dash 2 standard, which was the latest version is published 4 years ago at 2021. The health test is in the cross MQT module quality test number 7. The purpose we do it is to verify if the module is capable of withstanding the impact of the hail. Here from the in straight from the figure we can see the test equipment. Yes, and this is the equipment in our Rheinland Taicang lab in China. Yeah. Okay, from the standard, we have different test conditions. The diameter for the ice ball varies from the minimum 25 millimeters to the largest 75 millimeters. With different diameter of the ice ball, it has the different mass and also, of course, the different speed. Yeah. For the when we do the type approval and when we do the certification, the standards only requires for the minimum diameter, so which means only 25 millimeters. Yes, but when we consider in some survival weather conditions, for example, in the cities in Australia, when some in some circumstance that the hail is very big, then we have to consider the bigger one. Uh, we usually consider, well, for example, from the 35, 45, or even the 55, which is already a very survival test condition. And for about 655 and 755, they are mostly more suitable for the BIPV modules. For example, they are not for the traditional 2.0 and plus 2.0 millimeters half semi tempered glass module, but or even thinner like the 6 millimeter plus 6 millimeter, or even the uh, more like 10 millimeter and plus 10 millimeters, which will be bigger. Yes, from the last illustration that we can see the ice ball, how we prepare it. We have the template, yes, and the refrigerator is just near the test equipment in the middle picture. So when we just prepare the ice ball, we will use it immediately for the health testing. Yeah. According to the standard, we will test totally uh, 11 points. 11 points. you can see the left point is suitable for crystalline silicon PV modules, which are in most cases, and the right picture is especially for the thin film technology PV modules. Yeah, so we usually refer to the left one. We can see the different short points. Some are in the middle of the module to uh, verify the, for example, for the glass, for the solar cell, for the bus bar. So which means the cell connectors and the string connectors, if it can survive under the 25 millimeters or larger millimeters ice ball. Yeah, and also for some points are more concerned about focus on the age of the PV modules. Yes, to verify the frame for the other parts. Yeah. So I would like to share the test results of the performance of Trinasolar's panel. On October of last year, two samples from Trinasolar of the module TSM dash 6 110 610 NED 19 RC.20 was submitted to perform health test according to the standard IEC 61215-2 2001 version MQT 97 at the test lab of the Rheinland Suzhou cell at TD. Yeah, we can see the sample photos of the samples here for the front side, for the rear side, for the nameplate and its junction box. Yeah, also for the car page of our test report. Yes, from the tests, we tested on two samples for the both under the condition of the 55 millimeters, the very large hull ice ball. Yes, before we do test and after the hull test, we will do the visual inspection, do the maximum power determination, or we call the STC, to verify the output, if any losses after the hull test. And we will take the photos of EL images to see if any macro cracks occurs for the on the solar cells. And of course, we will do the insulation test, high power test, and the wet leakage current test. So the two samples were both submitted in the diameter of 55 millimeters, and the mass of the ice ball is around 80.2, and the speed is around 37.9, a total 11 points, as I set. So we can see the initial power. We normally care more about on the front side. So the front STC, you can see the module type is 610. So the real output is one is 6 and 11, and another is 16. Yeah. So when we finish the high test of the 55 millimeters, we can see the power loss here. One loss is at 0.95, 29 percentage, and another losses at 0.13. Both have a high performance, very high performance. Okay. So we can also see it from the EL images from here, from initial when we before doing the test and after we doing the test, almost no macro cracks. Another topic, what happens if solar uh, we know solar panels that are constructed will have a strong and robust layer of tempered glass or half semi-tempered glass that can withstand a significant amount of force. It's highly rated and capable of withstanding the efforts of moderate hail, and normally, which means 25 millimeters, allowed to be utilized outside for an extended period of time. Yes, we know the P modules will be used outside for at least, for example, for the single glass module, we will use at least 25 years normally, and for the dual glass, or we call double glass module, which will be used at the lifetime of around 30 years. So it's a very long history. So the degree to which the hailstorm harm to the solar panels is uncertain. we know in the spring, in the winter, or summer, autumn. Anyway, each cases and the varies depending on the homeowner's reports. Yes, some have observed with little or no damage, but others have some presence of tiny cracks or scraps on the surface. So uh, this product, after testing, at least we test from the test report, we doing the test on the two samples. It's performs very good, and it's not only for the visual inspection but also for the power loss. Yes, very low power loss. Yeah, okay. Another topic today I would like to share is around about the static mechanical load test. We know the hail uh, it consists of the frozen ice or the rain. Yes, when we have in other extremely weather conditions, we were considering about the strong wind, the heavy snow. Yes, uh, if the module cannot stand under such pressure, it will be cracked. Not only for the module itself, but also for the entire power station or our rooftop modules. Yes. So the reference standard is also from the 6.12.15-2 2001 version, and the cross is MQT module quality test 16. The purpose of this test is to determine the ability of the module to withstand the minimum static load. The minimum required design load for a particular site will depend on a module's construction, applicable standards, building codes, and probably for every occurrence. Design exceptions and the location or climate and might require higher sampling rate and other safety factors. Yes. The standard, the minimum required design load per this standard from the 1215 standard is the 1600 Pascal, and we will uh, multiply with the factor of the safety factor of the 1.5 at least. So from the results, we will test it at minimum test load of the 2400 Pascal. In older standards, we usually consider the 2400 Pascal is for the wind load, and the higher test condition of the 500 and the 400 Pascal is especially for the snow load. Yes, and also you can see some in the designation of the nameplate of the P module, it still calls wind load and snow load. Yes. Uh, on January of this year, also two samples from Trinasolar with the same module type were submitted to perform this test according to the standard in our laboratory in China. We can see we use the test method of the sandbags. Yes. Okay, we can see the samples how we install it according to the user manual from the Trinasolar, and how we perform this test. The test requires at least three cycles. One cycle consists of an hour of the front side, uh, and another hour of the rear side. So the total test duration would be 6 hours totally. Yes. Here we can see for the two samples, we also need for the visual inspection, for the maximum power determination, for the EL images, for the insulation test, water leakage current test, grounding continuity test, and what we care about is the static mechanical load test. We have from here we can see we have tested two samples. The first samples were tested under the condition of the 7,000 on the front side and the 5,000 at rear side, which is extremely larger than the which does for the minimum requirements of the standard is plus and positive and negative both for the 2,400 Pascal. This is extremely high. So for this 70 and 7,000 and 5,000, what we use the test method of the 4 mounting holes, 4 screws, 4 clamps, and 2 rails. This is the test condition. For another sample, we tested even a higher test condition of the front side of 8,000, and for the rear side is for 6,000. The mounting method is more survivors, and the last sample we used the total six mounting holes, 6 screws, 6 clamps, and the spring rails. We can see the although for the different test conditions for the part performance, we can see from beginning. Yes, here we can see here for the front side and for the rear side, and this is for after the test. We can see here. For the front side, the power losses is still within 1%, which is already quite good. And for the rear side, we can see even have a bit grow. Yeah, okay. Also, we can see from the EL images, similar like its performance, another 2 samples performance in the high test, almost no macro cracks when we tested. Okay, this is the what I would like to share. This all. Thank you very much for your attention. Thank you.
Thank you very much, Eason, for your great insight into testing standards. Our next presenter today is Charlie Chai, the Reliability R&D Manager at CGC. Thank you very much, Charlie.
Thanks, Andrew. Wait a minute. Let me show my PowerPoint. Okay. Good afternoon, everyone. I'm Charlie from China General Certification Center. Today, I'm going to talk about the reliability of PV modules under extreme weather. The whole presentation is consisted of 4 parts. Firstly, the background and introduction of the topic. Secondly, I will go deep into the influence of extreme weather and the relating tests to evaluate their impact. Thirdly, I will show the test results of non-uniform snow load of Trina's new product. Fourthly, I will look into the future. So let's begin. As we all know, the global installed PV capacity has been increasing rapidly. And not long ago, the Global Solar Council celebrated the historic achievement of reaching 2,000 gigawatts of global installed PV capacity. However, the data reported by insurance industry raised the concerns on module reliability. Under extreme weather, we can see from the right picture, snow pressure, storm damages, and hail. These weather-related damages account for 25% of solar claims volume, but more than 60% of claims value. And wind, hail, snow are reckoned as the most typical extreme weather. Here are some pictures showing their damages. Left one, rooftop solar panels destroyed by the violent wind in Nantong, China. Middle one, hail severely damaged in a solar farm in Nebraska. And the right one, heavy storm damages residential PV systems in Japan. To tackle with this extreme weather, several standards have been published to evaluate the module performance. Besides our type approval standards and international standard like IC standard, there are only 2 subjected to typical extreme weather. One is 63397 for large hail, and another one is 62938 for heavy snow. And so there are still some gaps between existing international standards, especially referring to mechanical load. The type approval test could not fully represent the real cases of strong winds. So the IEC committee is discussing to supplement more tests to mechanical loads like low or high temperature mechanical loads or non-uniform static mechanical loads. Okay, it's time to go deep into these 3 extreme weathers and their tests. First, hail. Hail is one of the most destructive types of severe weather. The frequency and intensity of hailstorms are projected to rise globally, with larger hailstorms becoming increasingly common in regions like North America and Europe. Both the frequency and the severity of hail are expected to increase. In contrast, Australia may see fewer hailstorms, though the size of hailstorms is likely to grow. Even in areas where hail is typically rare, the likelihood of such events has risen significantly. Right picture is a real case of solar farm in Nebraska, which suffered significantly hail damage. This project features double glass modules and utilized single axis checker. Based on visual inspection, the glass of most solar modules were damaged after hail. Moreover, those appear to be good might get micro cracks, then reduces the panel power output. Considering the destructive damage caused by hail, IEC TS 63397 aims to support in the selection of modules for specific regions with higher risk of hail and the improvement of module design. Here is the test sequence. Test screen. And next. Compared to IEC 61215 MQT 17, the main difference is the squeeze. And in this test, after module are exposed to hail stresses, the selected thermomechanical stress test highlighted in blue with dynamic mechanical load, thermal cycling, humidity freeze are added to amplify the influence of micro cracks caused by hail. The power loss from these modules is then compared to the reference module that has been through the same stress test except the hail stress. Okay, that's a brief description of hail. Next, I will spend more time on snowpack. Left picture is the global snow annual depth. Snow mainly appears in Northern Hemisphere like Europe, North America, and North Asia. Right picture show real cases of heavy snow. Top one. The white traces indicate the remaining influence of heavy snow on modules in Japan. Bottom pictures are from IEA PVPS Task 17 report, review of failures of photovoltaic modules. We can see ice layer slides over module's edge, which bends the frame. Also, the corner screw joints fail. A simplified force diagram that simulates the effect of snow is put here right. The inclined surface or top of the module. Simplify allows some snow to shift the load to the lower part of the module, which also induces a torture at the clamp force. The ice formed by compression of the lower snow areas pushes against the exposed tip of the frame. The whole snow load can be divided into two forces, downhill force, FH, and normal force, FN. As a function of the inclination angle, the downhill force increases the stress to the bottom of the module, potentially resulting in a lack of resistance for maintaining the structural integrity of glass. Inhomogeneous load cause moments and tortures in the lower parts of the module along the axial direction of the test specimen. The lower module clamps are subject to large moments, and the corresponding standard of non-uniform snow load test is 32938. To test, at least 7 PV modules are required. One is used as a control module. 5 or more modules are used to determine the maximum load bearing. Only go through humidity-free 10 cycles and inhomogeneous snow load test. One is used for One is used for determination of electrical degradation at a load below the determined maximum load bearing, which goes through a whole characteristic of measurement. After the test sequence is performed on a total of at least 5 modules, use those failure limits to calculate the final load value. Then apply the computed safety load value on a 6th module for at least 24 hours to evaluate any change of sample appearance, power degradation, and electrical safety and reliability. Less than 5% power degradation, no visual and electrical failures means the module passed this test. Besides the homogeneous snow load, low temperature may cause embrittlement of the adhesives and further reduce stability. The encapsulant storage modulus increases at colder temperatures, thus it deforms less at the same load. Moreover, the CTE differs between the frame and front glass. This CTE mismatch leads to a thermal stress in the front glass. Higher curvature and therefore a higher stress at frame edge due to increasing encapsulant storage modulus at colder temperatures. Higher thermal stress due to CTE mismatch between front glass and frame results in a higher first principal stress within the glass at cooler temperatures. Thus, it's quite necessary to involve the influence of low temperature into the mechanical load test, although the international standards of it haven't been studied yet. Typical mechanical load test is conducted at room temperature, which does not truly reveal the ability of PV modules to withstand wind, snow, or ice-covered loads. This test is harsh on module components such as encapsulation, backsheet, and frame, more close to the real field conditions that heavy snow covers the whole module. And left side is a picture of our CDC equipment. Thirdly, wind is also a typical extreme weather. Left picture shows the distribution across years of the fraction of continents affected by the most severe wind droughts. Regions like Australia and Europe is more widely affected by strong wind. In contrast, only a small fraction of Asia is influenced by strong wind. However, the frequency of severe wind droughts in Asia are obviously higher than other continents. The right picture is a region in Inner Mongolia, which suffered continuously gale force winds, with an average wind force of 8 to 9 and a maximum wind force reaching 11, causing tracker breakdown, frame deformation, and glass cracking. Considering the existing mechanical load test standards couldn't reproduce all the failures occurred outdoors, more research about mechanical load tests is ongoing, like low-high-low cycling test, non-uniform static mechanical load test. Low-high-low test is designed to facilitate and standardize the application of the pressure sequence specified in the building code of Australia. The table in left shows the cycling load value starting from low, then high to 100%, then low to simulate the wind load resulting from the passage of tropical cyclones across a building. This test can be used as a potential supplement to our module test. As for non-uniform static mechanical load test, which is also discussed in 2024 IEC TC82 WG23 meeting, this demand is derived from tracker manufacturers. Non-uniform static mechanical loads could also have impact on modules, so this test should be converted into module standards. Two similar procedures from tracker industry group to consider are UL 3703 tracker safety standard proposal for uneven load test and IEC 63513 tracker safety standard. The load distribution of each test is shown in this page. Basically, test is to apply uneven load to one side or another zone, then another side for some time, repeat for several cycles. This test is to assess ability of PV module attachments to the pure rings or rails to withstand a minimum static load. Part 3 will be the test results. Here, the test is detailed introduced in the first presentation. So here, this part will then focus on the test results of non-uniform snow loads. Initially, I will introduce the information of the measured module. The module type test for non-uniform snow load is TSM NED 19 RC-20. The maximum power of this type of module is 600 to 615 watts. Module features 2.5 millimeter double glass and the module size listed here. The images of module are taken from the beginning of the test. As described in previous slides, test sample number 1 is a reference, only goes through visual inspection, stabilization, and maximum power determination. Sample number 2 to 6 are used to determine the maximum snow load, which only do visual inspection, humidity freeze, 10 cycles, and maximum load determination. Sample number 7 is used to verify the determined snow load test, which requires almost all the tests except for the maximum load determination. Here is the test results of Trina's product. Modules are mounted through outer 4 holes with mounting rails across the long frame. Trina successfully passed the final snow load test with no visual failures. Right side is a picture of the final snow load. And looking into the maximum load bearing, 3 of the modules reached the maximum load of 6,600 Pascal, and 2 of them reaches 6,400 Pascal, which means the maximum snow load of TSM NED 19 IE-20 is 6,600 Pascal, which is far from for the need of Australia and East China. In maximum load determination step, the most common failure mode is long frame deformation. Here are 3 pictures of them, and we can see here it's mostly due to the long frame. And part 4, this part represents some tests that do not have corresponding IC standards. However, CGC recommends the industry to pay more attention and do more research on them. Hopefully, they could help the progress of module reliability and become the international PV standards in one day. The test results of low temperature mechanical load from 59 modules, including dynamic and static mechanical loads, are listed here. Those tests are operated under -40 degrees to simulate the field extreme low temperature conditions. It's quite obvious that low temperature static mechanical load is harsher than low temperature dynamic load, which is only 78 pass rate and higher degradation, which might indicate low temperature static mechanical load is the more representative test for ultra low temperature conditions. And another one, as I said before, low-high load test is used in Australia building industry. CGC managed to learn from this test and use it in PV modules. The tests here are only for research purpose. Results show that low high-low test is quite hard to pass. Module frame and mounting joints are more vulnerable during this test, which means we might need to pay more attention on frame and mounting quality when considering the impact of strong winds. In the end, I will make a conclusion of the whole content. While extreme weather can present a challenge for solar panels, they remain a reliable and sustainable energy solution for homes and business around the world. By reasonable product selection and system design, project stakeholders can prevent or mitigate many extreme weather losses. Hail, wind, and snow are the top 3 leading causes of insurance losses in field solar assets. The reliability of modules under most extreme weather can be evaluated according to IEC standards. Yet, there are still some gaps between the standards waiting to be filled. The test results show that TSM-NED 19IE.20 has an outstanding performance under non-uniform snow load with 6,600 Pascal maximum inhomogeneous snow load. And Trina has been always committing to module reliability for many years, striving for excellence and focusing on the real needs of customers. Also, CGC aims to take steps in reliability and keep pushing forward for the industry. And thanks, that's all for my presentation. I will stop sharing.
Thank you very much, Charlie, for that detailed presentation today. Our final presenter for today is Mr. Lim Chong Boon, who is the head of modules for Asia Pacific at Trinasolar. Thank you, Lim.
Hi, thank you, Andrew. So let me share my screen now. Okay, I hope everyone can see my screen now. Thanks again, everyone, for the time to attend the webinar today. I'm Lim. So these are the few contents that we'll go through in my presentation today on the PV application, requirements in the extreme climate conditions, how our new solution, Trina Shield, can mitigate this extreme climate solutions with superior reliability, and also how this climate solution will bring higher system value to all our customers. So if you can see here, this is the global expansion on the PV products that face diverse climate challenges. So throughout from the 20th century until now, the cumulative, there's like approximately more than 2.1 terawatt of PV power plant being installed on a global basis. So you can see here, the different severe climate conditions like the severe hailstorm, heavy snow, strong wind, cyclones, hurricanes that have the occurrence over different continents spread out globally. So in particular of Asia Pacific region, we face like the heavy snow conditions in Japan, Korea, then strong wind possibly in the Philippines, Taiwan coast, and also severe hail conditions in the Australia continent. So what are we going to offer to mitigate this extreme climate conditions? So actually, since 2019, Trina, we have already been looking at tailored solutions catering to temperature and humidity conditions. So by customizing the encapsulation materials in our modules, we are able to provide the right product to the right scenarios. As you can see, spread out over the world, there's different climate conditions, extreme cold, large daily temperature difference between day and night. And then we also have, particularly in Southeast Asia, on the high temperature, high humidity. And of course, I mean, the rest of the countries will fall under the normal conditions, which can be installed using the normal module solutions. So Trina solution on shield extreme climate solution, we are looking to target the several extreme climate. So one will be a hill. We withstand hailstones up to 75 mm. Strong wind production, front 8,000, back minus 6,000 Pascal. Heavy snow production with snow up to 2.2 meters. And also, putting all this together, we are able to give a higher system value to the whole project to reduce the damages which might happen from this kind of occurrence, lower the system LCOE. And as a single point, Trina can offer more reliable services, fast installation, and delivery of the quality service standards. So this is the more details on our NED 19RC.20, the shield module. So basically, we'll be able to cover scenarios as mentioned, the heavy snow, strong wind, severe hailstones, and also coupled with the high fire rating in terms of the safety level. And we are using our TopCon Ultra, so it can achieve a higher power wind with high efficiency. So on the right, if you compare with the normal module, you can see in terms of the hill, from standard 25, 35 mm for normal module, we have upgraded to 55 mm and up to 70 mm. Then similarly for the mechanical loads, standard 5,400 front, 2,400 back has also been upgraded in the maximum design condition, up to 8,000 Pascal on the front and 6,000 Pascal on the back. Then for the fire class itself, the standard module in the market or normal module market will be between class C or C plus C or A plus C. But for this shield module, we have also upgraded the fire rating to A plus A, so we can achieve a fire class rating A. So what have we done to our Trina modules and the overall solution that we are proposing to mitigate this extreme climate conditions? So on the left, you can see we have increased the thickness of the glass by approximately 25%. So this has helped to improve the impact resistance by more than 2.5 times compared to the normal module. So we have also optimized our frame design. So using this innovative frame design, we are able to upgrade our mechanical load for the front side by about 30% and the back side by about 67%. So now we have a very strong and reliable module that is able to withstand this climate condition. But we think that is not enough. So we combine it together with our Trina Tracker intelligent tracking system, which have the smart controller, which is able to have different store strategies when the tracker is on operation to monitor the real-time climate conditions and adjust accordingly, to really minimize any possible damage to the PV power plant. Similarly, we are also running the Trina Smart Cloud, where we are mapping the different conditions, tracking the health of the PV plants, to ensure that we're able to do early detection and preventive maintenance. So these are the details of how this shield extreme climate solution are able, or rather more superior to the normal solution. So on the left is all the advantages where for 55 mm hill, we can withstand this at 0 degrees flat, and then 75 mm hill at 60 degrees tilt. So with the Trina Smart Cloud, we are able to have a quick forecast, or the continuous monitoring of the climate conditions, the weather conditions, and then make fast decision, timely response to protect the PV modules and the PV plants. So we have also went through all the extensive testings as mentioned by the two speakers earlier. So we have got the testing reports, the certification. So with this, we are very confident to offer this module to be installed in this kind of extreme climate conditions. So of course, with all this in place, is also give a peace of mind to the project owner, to the insurance company, that this PV asset is going to be operational and for a long time to come. So this is some images that we share from the testing. So on the left, you can see using a standard 2+2 mm glass thickness. So when we are encouraging a 55 mm hailstone, it will crack upon impact. But for 2.5 plus 2.5 is still intact. Then on the right, yes, we already have a very strong and reliable module in place, but coupled with combination with the Trina Smart Cloud platform, where we are able to detect that a hail is going to happen. So we will stow the module up to 60 degrees to even prevent or minimize any damages to the PV asset. So this is a calculation that study that we have done on the glass breakage under different hailstone diameter. So you can see we have done this study in quite flat multi-county. This is in US. So this is a comparison between 3 different installation type. So the standard module plus 30 degrees tilt fixed tilt system. Then we have the Trina Shield module plus 30 degree fixed tilt system, and then the Trina solution with the 60 degrees tilt protection. So you can see here on the probability of glass breakage at hailstone 65 mm. So it's 100% chance that you will get broken glass when 65 mm hailstone occurs for installation type 1. But for type 2 and type 3, you can see the probability of glass breakage significantly decline from only to 30% chance of breakage to less than 5% chance of breakage in the 60 degrees tilt protection. So when we translate this into actual financial numbers, then you can see, if you're going to have 100% breakage, so the replacement cost of the PV assets is going to suffer a great loss in the monetary terms. But by using the Trina Shield solution, so you can see that we actually can reduce greatly the possible loss from the hailstone attack by 59% for solution 2, and then by up to 94% for the type 3. So this is the global severe hail distribution, which can happen suddenly and last for a few to several minutes. Then on the right is an interesting data that we have collected from a source GQ Insurance. So you can see, although the hail occurrence is actually one of the lowest disaster, but the damage cost is actually the highest, where we can reach up to 54% of the claims happening on the PV asset. So next, on the strong wind protection, so resistance to the damage and withstand the wind pressure up to +8,000 and -6,000 Pascal. So this is a very big improvement, or rather a very big upgrade compared to the current standard wind resistance of the 5,400 and 2,400 for fixed solution, and also the tracker solution. So coupled with a Trina Smart Cloud, we are able to monitor the real-time wind speed. So the tracker is able to have different stow strategy, which we will illustrate in this slide. So you can see for 8,000 Pascal and -6,000 Pascal is using a combination of installation hole and clamps with the 3-beam installation design. So this will be able to provide the multiple layers of wind resistance, which has already been certified, as mentioned by Eason earlier. Then on the right is the Trina tracker solution protection algorithm. So when the high wind speed is detected, so the tracker will adjust the angle, the snow angle itself, to mitigate this wind speed correspondingly. So with this combination of a high reliability module plus this tracker together into one solution, we are able to increase the mechanical load capacity to about 3,700 Pascal front and 3,700 Pascal front and 3,000 Pascal back. So we can see here the occurrence of a strong wind that is spread out on a global basis. Then on the right is some of the pictures that has happened because of this wind disasters. And next is on the heavy snow protection. So also as shared by Charlie earlier on the uneven snow loads, or rather uneven loads that might happen to the PV module. So for this Trina Shield module, we can withstand uneven snow load up to 2.2 meters. And at the same time, with the Trina Tracker Smart Cloud and also our Trina Smart Cloud monitoring, we're able to do the one-touch snow shedding, means putting the module into like 60 degrees snow angle, where it will allow the snow to slide off. So this will also clear any module obstruction in time. So you can see on the left is the picture shared earlier. On the right is the one-click snow shading, where you see when the snow occurs and start to accumulate on the PV module. So it's possible to do a one-touch trigger to let the snow slide off to prevent damage to the module and tracker, and also at the same time to continue the power generation so that there's no shading on the PV module. So yeah, this is the global snow diffusion. Then on the right, you can see what will happen. Some of the case study that has happened damages to the PV assets because of the heavy snow. So on the third section will be on what is the higher system value that we can provide to our customers from using this Shield Extreme climate solution. So this is a case study that we have done on the top part, a comparison between TopCon Ultra and the TopCon version 1.0. So you can see the module power itself, we have already upgraded by about 25 watts. So similarly for the backside, about 52 watts higher by efficiency factor. So all these translate to a more powerful module. Then coupled with Trina Tracker Super Track, where traditional algorithm only optimize the daily tilt angle, but Trina Super Track calculates both for the front and the back to give the additional energy yield of more than 3%. So we plug this solution into a case study based on Queensland, Australia, on the one portrait tracker. So you can see here, we are able to reduce the BOS cost of the project and also increase the overall value by about 0.03 Aussie dollar per watt. And in the terms of the LCOE, there's also a reduction of approximately minus 2.84%. So from design to concept, to finally being able to launch this product into the market was based on Trina's capability and history over the many years of R&D. So you can see, we have outstanding financing capability verified by different third parties, and also to ensure that our product are able to, or our solution are able to meet what we have assured. So we have also done testing with a different certification body to get to show that our products are capable of what we say. So same for our Trina Tracker solution. We also want to help our customers to have more optimized installation and also on the cost saving. So some of the solutions that we have will be on the factory pre-installation of some of the components for the tracker, and also innovative on-site fast installation method that we can help to save the time and also optimize the labor costs. So when we use the Trina Shield Extreme Climate Solution, so what you are getting is a whole suite of services. So with the Trina Smart Cloud, as we mentioned, it's an intelligent monitoring system where you already have a very strong and reliable product, but coupled with the Smart Cloud, we are really able to minimize any possible damage to the PV asset to the lowest. And then for Trina modules with Trina Tracker, so we have also done the compatibility testing. So we're able to issue compatibility declaration letter in a swift and efficient way. And on the right will be a unified warranty window where priority troubleshooting and resolution on the after-sales service should anything happen, compared to where you have separate suppliers for modules, trackers, and other. So there will be different multiple parties interface when we get into the unfortunate event of the sales. So in terms of the mass production timeline and the supply capacity for the Trina Shield module NED 19RC.20, so we'll start in 2025 Q2 with an initial supply of 5 gigawatts. So lastly, in summary, we have went through from point one, Trina Shield Extreme Climate Solution, up to 75 diameter hailstones, very high wind resistance, wind load, and up to 2.2 meters thick snow. So by deploying this solution, the Shield module plus Trina Tracker, we are able to reduce or minimize the possible losses to PV assets in extreme climate conditions, but we also enhance the customer value in the various scenarios and also help to reduce the LCOE. On the third, together with the innovative Trina trackers, we can install faster with the pre-installation options and also the different components to improve the on-site construction efficiency. So lastly, point number 4, we will start this module production in Q2, starting to supply with a scale of about 5 gigawatts plus, which you can adjust quickly depending on the supply-demand situation. Okay, so with that, I've come to the end of my presentation today. Thanks again, everyone, for the time.
Thanks very much, Lim, for a great presentation. We've probably got time for just a couple of quick questions, and some have come through. I think they're for you, Lim. We've got multiple customers here. They've inquired whether Trinasolar's solution can be used in areas with strong winds in the Philippines and Australia. What should be considered in the project design, and can you provide any relevant product materials?
Yeah, hi Andrew. Thank you for the question. Okay, so I think the product itself coupled with the solution, Trina are able to offer the correct proposal. So the module, the NED 19RC modules can also be used in strong wind regions like in the Philippines. So we welcome customers to contact us with their project details, requirements, and then we can give the most suitable and feasible solution to our customers.
Great, Lim, thanks. And last question here, compared to other product solutions, what are the standout advantages of Trinasolar's solution?
Yeah, so for the Trina Extreme Climate Solution, as shown in the slide earlier, we are a one-stop shop. So we have the whole suite of services that we can offer to our customers, faster installation, compatibility letters, and also the unified after-sales window.
Great, thanks, Lim. Thanks very much to everybody for taking some time out of your busy schedules to join us today, and hopefully this session provided some valuable insights into enhancing the resilience of your solar installations against extreme climate changes. And we look forward to further discussions with you as we address your questions after the webinar. Thanks again, everybody. Have a great day.
Thank you.